Okay. Let me ask you this. For the case of turbulent flow, is it really uniform distribution?
Not really.
So, is this uniform distribution in turbulent flow?
Not really. It looks like a uniform, but it's not.
We don't have bubble stick at the wall, right? But we have water or liquid phase stick at the wall. So at the wall, it tends to have more hole up than at the middle, correct?
For laminar or turbulent?
For turbulent flow. For turbulent flow, liquid phase touch the wall all the time, right? But bubble, when it hit the wall, it kind of bounce. So near the wall, we have more hole up than near the center, intuitively. So theoretical prediction won't match to the measurement. What do you believe? Measurement, right?
Yes.
But it should be close. Okay. So the solution, please take a look at it. So I'll have to test you for sure about that integration thing. Okay. It is going to be in the exam. Whether it's 0.25 or a laminar flow case, and I may give you a different kind of distribution of the bubble. Okay, I may say, okay, bubble distribution is peak at the center and it go down linearly, can be, or it do like parabolic shape, it can be, and do so for it. And that is actually in the solution already that I'm going to post. Okay, next in the exam will be certified flow calculation.
Question. How does this thing that we're trying to derive affect the other parameter?
Okay.
The other
So this thing that we deriving, why should it be matter? It doesn't matter for the case of water. But if let's say we do the research on the case of high viscosity oil. So C value and C0 will not be 1.2. Okay, it will be something else. And we have to find out what is that something else. So C0 will impact translational velocity, VTB, right? VTB in your book, we haven't talked about it, is VTB equal to C0 multiplied by Vm plus V drift velocity. So translational velocity is a function of C0 or distribution coefficient or distribution parameter.
I think it's because of critical Reynolds number.
Critical Reynolds number?
That's what has shifted from maybe.
Yes. For turbulence and laminar flow, the way that the bubble distribute inside is not the same. Velocity profile is not the same. So C value change. Okay. All right. In the exam, you should be able to convert from height to hole up and hole up to height. Okay. Aya, how do you convert from height to hole up? Which equation?
HL tilde, if we had the formula.
So you calculate AL tilde, right?
Yes.
Okay. What about if I give you the hole up? Can you calculate
By calculation.
height?
Wait, say again. Why we?
Height and hole up and height.
Why would
3.38.
No,
AL tilde equal to something.
Well, you said it dispersed flow.
No, I'm talking about the exam. In the exam, if I give you height, can you calculate
Oh, yeah.
hole up?
Yeah.
Okay. If I give you hole up, can you calculate height?
Yes.
Really?
Is,
How do
it,
you do
is it
that?
like,
Yes.
it's not
Yes.
perfectly explicit, you know that.
I
Yes,
mean,
but
if
you
So
you
probably
have
it's gonna take time.
you have to then program, I guess, your calculator, right?
Yeah,
So
it's
you-
not.
you
Is it
reverse-
explicit? We have
You
no.
reverse the equation
You-
and use.
No, it's implicit. Because AL tilde is a function of edge, and there are several edge appear.
Yeah. So
We cannot say edge equal to some function of A. We cannot do that. However, what can you do during the exam is, you may say, okay, let's try edge equal to 0.5.
Oh, that's oh,
it doesn't need to be exact.
you want.
I may say,
Trail-
okay,
trail on
give
that.
it in plus minus 0.05. So if hold up is 0.5, what do? Height is also 0.5, right? HL theta is also 0.5. But if hold up is 0.2, what is your height? Or 0.21, 0.2 may be easy, too easy. So if it is 0.21, what do? More dear, any idea?
I'm gonna program in my calculator.
Okay, what you can do is your program to get hold up based on height is one click, right? Just push it, it's done.
No.
It is that fast, isn't it, Vega?
No, we can use that.
So Vega, how long does it take for you to calculate hold up based on height?
If I know the height, it takes me just one click.
Look at that. Okay, can you share your trick? How do you do that?
But you said it was
Just
vice versa, that you have hold up and want to calculate.
Oh, okay,
Height.
we will talk about that. So can you share your trick, Vega?
It's not really a trick, I just program the
What's your secret?
equations into the calculator and it asks me what's the height and I give it the height and it gives me the hold up.
Just one click, right? So let's say you don't know the height, but you know the hold up equal to 0.2.
Yeah.
Okay. So can you set your height equal to 0.2 and calculate hold up? Yes, of course. Right? Can you give your height equal to 0.25 and calculate your hold up?
Yes, that's true.
Yes, of course. You can do 5 click. Okay. Height equal to 0.18, height equal to 0.19, height equal to 0.2, height equal to 0.21, height equal to 0.22, height equal to 0.23, and find out which height that give you close to the given hold up. Done. Right? Or maybe you need another 5 click if you want more accuracy than 0.2 something. Correct? So you bought $41 calculator, or maybe cheaper. I want you to be able to use it to not full extent, but to some extent.
Like $30
Use
of
it.
it.
Okay. So you don't need to solve it analytically or numerically in your calculator actually can do it. Okay. You don't even need to use successive method. If you can calculate forward very quick, do that several times and tell me, is it 0.18 or 0.22 that make it match closer? If it's 0.22, is it 0.225, 0.222 or something? You can do several times, right? So if I just want 2 digits, 10 seconds, 2 minutes is done. Okay? So that will appear in the exam for sure. I promise, okay? It will be in the exam. So what about laminar flow or no, stratified calculation? If I say, okay, hold up equal to 0.2, the flow pattern is stratified smooth. Calculate pressure drop. Can you do that? And I tell you, okay, VSL, VSD. Okay, Vega, what do you do? If you know VSL, VSD, hold up is given, and I tell you that it is stratified smooth. What do? How do you get pressure drop? Is the equation in your head already?
Page 67.
You have the book?
Like homework.
It is easier than homework. So Vega, what do?
Are you going to ask us about flow time?
Oh, that will be another question, but let's try this one if you can do it or not. I give you VSL, VSD, hold up, and flow pattern, stratified smooth. Arya, what do? What is your first step?
So the equation that we have is force momentum balance.
Okay.
At the end we have everything. And actually what I have in mind is that I have to have all the equations just to copy and paste.
Okay. What you want to do is, you want to use your calculator, put in the hold up, and, or maybe I tell you height, maybe it's easier. Tell you the height, HL then you put in your calculator, you get AL, AG, SL, SG, SI, everything, including HOA. Okay, and then you can get AG, right? And from VSL, you can get actual VL. From VSG, you can get actual VG. Then you can calculate shear stress. Make sense? Yes, question?
So you know that all of the question you're talking about are lengthy and
It's not lengthy.
No, no.
Great God, how long does it take for you to do
let me
it?
finish.
Well, it's not your reference, you're not doing student in class.
It's not sure.
A long time.
What?
I haven't done it yet, so
So if I give you the HL though, how long does it take for you to calculate AL though?
AL tutor.
Yeah.
That's pretty quick.
It's
2 seconds or what?
No.
5 seconds. Okay, what do you want to say?
I say since it has
Oh, you have to program it.
lengthy calculation, so it's probable to have numerical errors.
No, it
Small.
won't. It won't. If you program it in your calculator and you check before doing the exam.
And
Or you give
That
it
it
done
give-
ahead of time.
No. You check with the known value. For example, if you do the homework and you actually my template is already available. That I didn't post it yet, but it's available.
That's true.
Okay, so if you know that HL equal to 0.5, AL tilde will be something, so you know the known value. So you can check whether you program it right in your calculator or not, right? How long does it take to program it? 2-3 minutes. Okay. 2-3 minutes. Okay, how long does it take to read the instruction? At most, half an hour, probably 15 minutes. So you read the instruction in your manual, you have the calculator. You read the manual, or buy it, okay? You still have some time to buy it. You read the manual and say, okay, how do I program it? It's not that difficult, you just put in. If you have any question, go to see Becca or me. So you have your program, you push the button, it gives you value. 1, 2, 3, 4, 5 seconds, 10 seconds at most. And you get AL, TDO, AG, TDO, everything. Quick. No Excel is available, okay? So then you can calculate every parameter and you can get friction, right? Okay. So can you calculate without using any chart? Of course, I give you the chart for H value. Can you calculate can you determine the flow pattern? Yes, of course. Check condition A, B, C, D. Okay. How long does it take to check that?
1 hour.
Oh, it could be
1 hour.
half an hour
No, 1 hour.
or 1 hour
Yes.
if you didn't program it in your calculator. If you program it in your calculator, how long does it take for that?
I don't know, I haven't done it yet.
Okay. It takes a while it takes you about 1 hour to program it. Or maybe it could be 2 hours to program everything. But this week we don't have homework and I expect you to spend 6 more hours on this. Plus, you already know what is in the exam. Okay, let me repeat. Change AL to HL, HL to AL. That's number 1. Number 2, calculate pressure drop given the height VSL, VSG. That's number 2, right? Number 3, flow pattern determination. That's number 3. Number 4, that integration that you just did. But this time, it will be, let's say, parabolic profile. But parabolic profile is the same as the solution that I'm about to give you, so I have to do something else.
It's fine.
Okay, it's fine. So there's 4 of them. 3 of them you can do it for sure. The last one, that integration part, read the solution a little bit and it's just fine.
So Professor, when we write the answer, you wanna just exact answer, that's it, right? Because
I want the procedure. The procedure doesn't need to be everything. It should be enough for me to know that you didn't look at anyone else and copy the answer and put it down. I don't want that. For example, if you do stratified pressure drop calculation, you write the governing equation, okay, and you may circle this term 1, this term 2, this term 3, this term 4, and you one circle equal something. So term 1 equal to this, term 2 equal to this. You don't need to define if you have time, but you probably have time if you do everything in program. So you can say, okay, P is pressure, AL is this, is no, don't do that, don't do that. If you don't have time, don't do that. If you have time, do that, it's fine. If you're about to submit and you have like half an hour left, okay, do it. If you don't have any time left, don't do anything like that. So I want the calculation step. For example, if you need Reynolds number, okay, to calculate friction factor, I need to know Reynolds number, right? If you jump from start and give me, okay, pressure drop is this much, then you get 3 points, okay? So I need to know Reynolds number. What's your Reynolds number? You have to calculate Reynolds number, right? How much is your friction factor? F equal, it's not that, it doesn't take that much time, right? F equal, RE equal, quick, right? And if it is 4,000 something and you get Reynolds number of 18, redo it, okay? It's not 18, okay? Yeah, where you get that? Okay. All right. Why do we do all this integration? Okay. Because everything that we are going to do is not just about air, water. Actual case is oil, and if you do research, it will be maybe high viscosity oil, and you have to do the test, and you have to check whether it's right or not, right? And you may need to know, okay, you're going to do the measurement. How is your derivation? Okay. So if you derive it and you found that, okay, the range is between 0.25 to 8 or something, and you check with your experiment. So now you have something to check against, right? So, okay. Danny, would you like to share with me why do we need to know all this derivation? How can it help you when you actually work? Please.
Sorry, because I have another point in my mind. Right?
Okay.
But well, can you repeat the question, please?
So all this derivation, integration, what do you need to know? What do you need to be able to do it? How does it relate to your work? Okay.
Well, we can say,
1 minute, okay.
Yes, we can say that it is going to yes. Can I share that explanation later, Professor? Because
Okay.
in 1 minute,
Raymond.
right now I am not going to.
Raymond, what do you say?
I am just thinking in the exam, and I think it is not going to be a good picture. So my mind.
Okay, let me summarize it for you. When I think about this, okay, let's say you get PhD from this. You are doing PhD, the derivation, it is a must. Because when you do PhD, you have to do research, right? People expect you to be able to do research. When you do research, you have to do something new. To do something new, you have to be able to do something that is old already. Of course, it's 1975, right? Some model is 1975. If you cannot do it, the newer one is a lot more difficult than that. So you have to be able to do it. Okay. For PhD student, I think it's very clear, crystal clear. If you cannot derive, if you cannot do integration, okay, go home, read a book, please. Okay, because you're not ready to do research yet. What about master students? What do you after you? So for PhD, it's a part of the requirement for you to do any research, right? You got to know it. For master, when you graduate, okay, I have how many years? If you don't count my postdoc or my study that I work part-time, so I don't have any industry experience. However, I have my friend who work in industry, okay? Several of them graduate from Tulsa with master and get a job. Do you know what they do? They work in Schlumberger, and some people work, what did she work? I don't know. I have known several people work in Schlumberger, and what they do is the work that bachelor degree student cannot do. Okay, the work that bachelor degree student cannot do. And when someone who gets BS, bachelor degree, cannot do it, they ask a question of their, may not be their boss, maybe like co-worker. So when you just graduate with master, you get in the company, you are not the boss, okay? Not the boss yet. But when your peer get bachelor degree, ask you the question, where do they get stuck? Of course, something that you know better than them, which is, could be mathematics, integration, all that thing, okay? So you have to be able to explain it. Plus, my friend do program developer in Schlumberger about Auger. So when you do Auger, the equation that you are about to face when you graduate is a lot more complicated than this. A lot more complicated than this. And you want to be able to derive it. Because every time that you read a paper, it's not correct. Most of it is correct. But there's a chance that one letter is missing, two letters is missing, or some symbol is missing, some explanation are missing. Most of the time some explanation are missing, and you try to, hey, the publication is there already, you don't need to do any research, you just read it and program it, go and do it. Your boss maybe just ask you this. So how do you know that? There's, you have master already. So master is not expected to be able to do research, but with the proper information, you should be able to code, right? So how do you know that the equation is wrong? Most of the time, there's something wrong in the paper. There's a typo. Okay, there's a typo. For example, if they forget to change minus sign to plus sign, how do you know that? You never know until you derive it. Okay, let me give you one example. Chang Unified Model is very good model for heat transfer multiphase flow calculation. In the paper, there's some place about plus sign and minus sign. Okay, so we never know that it's a mistake until you derive it. Okay, so if you, and when you get trained to do the derivation in your company, no, they don't train you any of that. They can train you about the application. Okay, this application work like this, okay. But that's come with your work experience, right? Do they train you about mathematics? No, they expect you to know that since undergrad. But I know that it's not like that. So we train you more, okay? And another good thing is when you develop, okay, I try to not talk about this much and try to go to the lecture, okay? But not just 2, 3 of you, but many of you may have doubt. Why do we have to talk about integration? Why do we have to go in every step in the model? Because in the book, the formula is there, you can just use it, right? Okay. My explanation is this. To be able to use it is fine, but not every time it's correct. Plus, when you know how to derive it, you trust yourself more than the book or more than other people. Okay. Maybe not yourself, but you trust in the evidence. I want you to have the mindset that you don't believe it. You don't believe in anything until you see the evidence. So you become reasonable person, right? Let's say somebody else have a lot better credential than me and tell something to me that, okay, this is like this, but this obviously is not correct. So you have, what do we call, intellectual maturity to be able to tell them that the reason that I disagree with what you have is because of this. Okay? So you got to be able to do derivation, need to understand every step. Doesn't matter if you do master or PhD. Okay? And of course, if you can be replaced when the oil price drop, you get laid off. Okay? But if you know more than other people, you won't get replaced. You stay. Isn't that good? Feel good a little bit? Okay. So application, it is important, and I expect you to know more when you do the job. Of course, there's a difference between someone who has 0 years of experience and 30 years of experience, right? There's different, right? Mathematics is what you have to compete with other people who have a lot more experience than you. Okay? So someone who has 10 years experience doesn't mean that he cannot be correct. Most of the time he's right, okay? Most of the time. But sometimes it can be wrong. And when you use a paper, manuscript, scientific manuscript, you read it. If there's a single symbol that is missing when you program it, program doesn't work. It has to be 100% correct when you do programming. So most of the tasks that undergrad cannot do, but you can do better than them, some kind of programming. Field engineer, anyone can be field engineer, right? They can train you for 3 years, okay, be field engineer. But think about something that Why do you need to get master degree? What is the difference between master degree student and bachelor degree student who graduate already and have, let's say, 10 years of experience? Why don't they have someone who has 10 years of experience with bachelor degree do your job? Why do they hire you? They actually need to hire you because you know a lot more than them, and you probably not have much more work experience, but you will be more intellectual maturity than them, more mature compared to them. So you have a confidence to say this is right, this is not right, and this is the reason for it. Okay? It's not just about your work experience, but also intellectual maturity. That will come when you train yourself more. Train yourself more means what? Do more homework, do the revision, understand each and every step. And later on, after you get a MS, you can do a PhD if you want to. Do an explanation?
This is
Yes.
best speech.
Yes, that was outstanding.
Professor.
I try to minimize this because I thought all of you know it. But couple of you bring to my attention that, hey, why this important at all? Why don't we just use a formula and go on? And all that are the reason. You want to get a job, a good job, and you don't want to be replaced. You want to know more than other people. If you want to get just a formula, get bachelor degree, you can be very rich. Okay. Bachelor degree, you use a formula, and the formula is right. You check against several sources. But there got to be something more when you do MS, graduate level. Okay? And I hope I explained that well. Sweta, what is your comment? Do you agree, disagree?
Yeah, I agree.
Yeah. Siri, what do you think? Is this mathematics or this revision? Is it matter to you?
Yeah.
Yes. Is it important, Uyne?
Yeah.
You think so? Okay. Anders, what do you think?
Yeah, that's important.
Yes, okay. Now you may see very clear. Why do you need to understand more? Okay. You remember first time that we do introduction to the slug flow, I said the integration is not right. The integration formula is not right. I check again, it is actually correct. I get confused a little bit. Actually, we do the integration in the moving coordinate. Okay, the integration solution is correct. And if you integrate it, assume that velocity is not a function of length, you approach the solution, the simplified version of the solution. You see what I'm saying? The first time that we have 3 slug flow, you remember the picture, slug flow and have solid particle inside? Okay, you remember that?
Yeah.
So the solution I gave you that I thought is not correct is actually already correct for the integration form. Okay, we don't explain any of that. And that is not in this exam. Let's put it in the next exam instead, okay? This time is too crowded already. I update my slide. I feel that some part of it is quite confusing and we moved too slow last time. Okay, this part that I want to tell you about is Doppler Hubbard model. Okay, in this slide I changed something. Oh, I'm sorry about that. In this slide I add one. Okay. Look at this. I add this line. DH model predict forward flow at HE. Okay. But actually what happened is backward flow or no flow, right? When you have inclined flow can move backward. But Doppler Hubbard predict what? Forward flow, which is HLTB is negative. HLTB negative in the Z direction. So it's move forward. So I think I didn't show you well, but this time let's go over this one more time. Sin beta is positive. Okay. Tau is like that. And from the derivation we see that VLTB, when we have equilibrium level, at equilibrium level, numerator is 0, right? And VLTB is negative. Negative means forward flow. So Doppler Hubbard model predict that the liquid inside the film move forward, even though it is at the equilibrium level. What does that mean? That means it's wrong. It is wrong, and it is okay that it's wrong because Dr. Bhavat model is for only for the case for horizontal flow. You can use it for inclined flow. It gives you something. It's better than just pure guessing, but it's not that accurate. So in your book, once we get HE, I don't ask you to find the page number, okay, because everything is on the same page, okay. Once we reach equilibrium level, you see this dHF by dZ. Once it reaches 0, it stays constant. Okay, that's what your book says. So when you do integration, liquid level go down and it reach constant liquid level. Next point, height is the same. Next point, height is the same. Next point, height is the same. Keep same thing everywhere. Okay, so that's why they said equilibrium liquid height. Once you reach equilibrium liquid height, the height remains the same. Mathematically, think about this. So you do the calculation until height equal to 0. Okay, or not height equal to 0. Slope equal to 0. So if you use explicit Euler, you use slope at the current point to predict the value at the next point. Okay, when you use the slope at the current point, the numerator is 0 already, so slope is 0. You move to the next point, the numerator stays 0. You move to the next point, the numerator stays 0. Why the numerator stays 0? Look at this. Your numerator is SF, right? SF dependent on liquid height. Correct? SF dependent upon liquid height. HLTB, of course, dependent upon liquid height. G constant, rho constant, AP constant, psi delta constant. Look at tau F. Tau F is VF, F sub F. Okay, F sub F is dependent upon Reynolds number. Reynolds number is velocity and the cross-section area, right? So cross-section area depends on liquid height. What about velocity? That velocity is VLTB. So friction factor is dependent on VLTB, velocity inside the film, and liquid height. Okay, you got this idea. What about VLTB? VLTB, is that dependent upon liquid height?
Yes.
Oh, not quite clear. Look at the equation that you have for F. X equal to, okay, mass balance. You see this. X is constant. Okay, X is constant. H out, so VTB is constant, right? VTB is constant, X is constant. If you reach the equilibrium height, you predict that the next point, height is the same. When the next point, height is the same, means VLTB is a function of height. Height only. X constant, VTB constant. So the velocity is dependent upon height. Okay? In order to have a mass balance, velocity inside the liquid film is dependent upon height. Okay, so that X is constant. So when VLTB is dependent upon height, this means once you reach the equilibrium liquid height, the next point you will predict the same height. When you get the same height, the numerator stays 0. When numerator stays 0, you predict the same location to be the same height, and numerator stays 0, so it stays 0 all the time. So both explanation in your book and mathematically, once it reaches that point, it's just 0. So this means Dr. Harper model predict that it go down, reach the equilibrium, and stay 0, stay constant. The height stay constant. What happens if you have upward flow? Why Shoham book say Dr. Harper doesn't work? So look at this. Okay, I add 2 modifications. Add this line, add that line. Okay. So once it reaches equilibrium liquid height, Dr. Hubbard predicts that the velocity is forward. Beyond that point, velocity is forward. Velocity is forward. So Dr. Hubbard model cannot predict the backward flow. to begin with. Because the Jacobian equation is only for horizontal flow. Okay, so this is the problem. So double Hubbard model cannot predict the backward flow. Okay, let's say we use it right, we use it for horizontal flow case. For horizontal flow case, what do we have? Theta equal to 0. Right? Theta equal to 0. At theta equal to 0, at equilibrium liquid height, what do we get? So sine theta is 0, so this term is 0. So in order to reach equilibrium liquid height, tau has to be 0. How do we get tau equal to 0? VLTB has to be 0. This term, VLTB has to be 0. So this means once you reach velocity inside the film, keeps lower. Once you reach equilibrium liquid height, at that point, actual velocity VLTB is 0. Film doesn't move. When film doesn't move, next point is stagnant like that. When we have this, you remember when we do mass balance? The equation for mass balance is VTB minus VLTB multiplied by whole up TB, right? Equal to VTB minus VS multiplied by whole up of liquid slab. You remember that? Which equation in your book? This is really important, you have to memorize it almost. Okay, open your book and tell me the page number, equation number. In your book it says VTB minus VLTBE, but it doesn't need to be E. So which equation that I'm talking about? Page number? 92. Go to 92. 3.87. Equation 3.87. You see that? Okay, so that is mass balance. So that equation must not be violent. Alright? So we can use mass balance. When VTB equal to 0, put it there, then we can get the height. So we get HLTBE equal to 3.7 something? 3.87. Manipulate it a little bit, so you get equilibrium whole up equal to right hand side of that equation divided by VTB, because VLTB go to 0 already. And if you think about it, VTB minus VTB divided by VTB is 1. Vs divided by VTB is something less than 1. So this equation telling you that the equilibrium liquid height is thinner than, or is less than hole up inside the slab body. So hole up at equilibrium is less. How much less? This much less. Okay, so the thinness location, it should be that. It should not be any thinner than that for horizontal flow. For outward flow, you can have backward flow, right? That you have seen in the lab. So when you have backward flow, look at 3.87. What is that telling you? You have left hand side is VTB minus VLTB. But VLTB become negative, so minus of minus is plus, right? So this term, denominator, can be greater than VTB. So this predicts that the whole up is even less or something when it, is it less?
Yes.
When it's falling back, okay? Alright, so now you get this slide that I didn't explain it clearly. So this time is clear that the purpose of this slide is to show you that double Hubbard doesn't work for angle more than 0. Okay, if we talk about this integration, I don't expect you to be able to do this, but okay, do this. What I mean is, you see, I have more dot over here, and I have less dot over here. Less dot per horizontal length. But if you look at it, it's like along the curve, the number of dots kind of quite uniform. Along the length is quite uniform. This is done by use RKF 45. RKF45. RKF45 make more dot when discretize more when we need to discretize more. RKF45. I don't expect you to know this, but what you should know is how do you solve with just explicit Euler? This is like very easy, right? Explicit Euler, what do? You calculate the right hand side, you get some number, you say, okay, that's some number, right? So you say it is linear. You do linear extrapolation based on the slope that you get.
For a small section.
Then you can guess the height at the next location. When you reach the next location, you calculate the slope again, right hand side. You get some number, right? And that number is the slope at that point. And you say, okay, use linear extrapolation based on that slope. Extend the line to get the next point. Une? Confused?
No, it's good.
It's clear. Tolani? Clear? It's okay. Alright. It's 5:51. 1 minute late. Let's meet at 11. Okay? See you later. Bye bye.